So today we are going to discuss about the photodiode. First thing is photodiode, characteristics of photodiode. Photodiode is very similar to the LED experiment. So in that LED experiment, we are going to connect LED in forward bias. So by connecting in the forward bias, we are going to find out the VA characteristics. This one. When we are taken voltage on the x-axis and current on the y-axis, in forward bias, when it is connected, it acts as LED. So LED up to particular voltage, current will not allow from the LED. After that, it started to increase. It started to allow from the LED and further increase in volt potential. What will happen? Current also increases and obeys the Ohm's law. This is we are finding in LED, VA characteristics of LED. So same thing, LED connected in the reverse bias, it acted as a photodiode. So it absorbs some light energy and converting into the electrical energy. So for different intensities, how much the current is allowed from the LED in reverse bias, we are going to observe in the photodiode. So when we draw the graph for the photodiode characteristics, we are getting the curves like this for different intensities. This is the intensity 1, higher intensity 1, this is the intensity 2, and this is the intensity 3. So in that coming to the LED characteristics diagram, so we are coming from the variable power supply. Power supply is connected to the resistor. Resistor is connected to the ammeter. Same thing in the diagram. Ammeter is connected to the voltmeter, positive, and negative is connected to the battery negative. So parallelly we are connecting any one of the LED from the voltmeter, right? So here connected in forward bias. LED is connected in forward bias. When it is connected in the reverse bias, there is a circuit diagram for photodiode. So by connecting in reverse bias, we are going to find out VA characteristics of photodiode. By applying the potential, what will happen? So in the reverse characteristics, what will happen? Only negligible current is allowed due to the minority charge carriers. So in that photodiode also, what is the function of photodiode? Light energy converting into the electrical energy. So for different intensities, by applying the different intensities, we are going to find out the VA characteristics of photodiode in this experiment. Now all of you try to watch the video first of all. After that, so I'm going to explain a little bit clearly about photodiode. Very similar to the LED experiment. No, I just is the screen is visible to everyone, Amma? Is the screen okay?
Yes, sir.
So once see audio also coming or not, once tell me. Audio కూడా వస్తుందా అండి? ఆడియో వస్తుందా?
Yes, sir.
Okay. So watch the video, Amma. Photodiode experiment. After that, we will discuss about that photodiode clearly.
Hi everyone, I'm Sujani, faculty in physics at Institute of Aeronautical Engineering. Today we are going to see the demonstration of the experiment, how to study high characteristics of a given PN junction or a photodiode. This is a brief outline of the circuit diagram, procedure, the observation table, calculations, model graph, and the
wait, Amma, wait.
These are the things which you need to ready with the experiment.
వీడియో ఆడియో బ్రేక్ అవుతుందా, వీడియో స్ట్రక్ అవుతుందా?
సార్ ఆడియో ముందే వెళ్ళిపోతుంది, వీడియో వెనకాల వస్తుంది సార్.
అది నీ దగ్గర ప్రాబ్లం రా
సార్ అందరి ఏమో సార్. ఒకసారి రేస్ హ్యాండ్ చేయమనండి సార్.
ఒక్క నిమిషం మళ్ళీ ఒకసారి ప్లే చేస్తాను.
ఆడియో బ్రేక్ అవుతుంది సార్.
బ్రేక్ అవుతుందా
సార్?
సరే చూడండి, ట్రై చేయండి. ఇంకా బ్రేక్ అవుతే ఆపేసి నేను క్లియర్ చెప్తాను. మళ్ళీ ఒకసారి ట్రై చేయండి, మళ్ళీ ఒకసారి ప్లే చేస్తున్నా.
ఓకే సార్.
ఒక 1 మినిట్ అయితే సెట్ అవుతుంది. అప్పటికి కూడా డిస్టర్బెన్స్ వస్తే నాకు చెప్పండి. ఓకే
ఓకే సార్.
Now the aim of the experiment is to draw the VI characteristics.
వినిపిస్తుందా?
VI, V stands
ఆడియో
for
వస్తుందా?
voltage and I
లో వస్తుంది సార్ సౌండ్.
వాయిస్ ఇంక్రీజ్.
stands for the current. So we are going to study the voltage versus current characteristics of a given photodiode for different light intensities. We are going to vary the light that is falling on the photodiode and then study the characteristics for various light intensities. Now the apparatus required. Here we'll be using a photodiode trainer kit. So this is what is shown in the diagram. This is the trainer kit, which consists of all these components inbuilt. We'll have a photodiode, okay? A photodiode which can be connected between these 2 points and a variable power supply. The power supply is there. We will just connect it through with the help of wires. We will just do the external connections, take the power supply in the circuit, output to input. And we can also vary the power supply with the help of the potentiometer. An ammeter to measure the current. So this is the ammeter we are using here. So we have 2 different modes. You can either put it in the milliampere mode or the microampere mode. And because we are doing this experiment in the reverse bias, because the PN junction works in the reverse bias, so the amount of current is due to the minority carrier. So we will be using it in the microammeter mode. So you can use the microammeter mode. Then a voltmeter to measure the voltage. So we have an voltmeter. This is the voltmeter. And a resistance, a fixed resistance of 1 kilo ohm is already fixed. And then a light source, a lamp we take from which the light will fall onto the photodiode, and then some connecting wires, the wires to connect, do the external connections. Now this is the circuit diagram for reverse bias. We are talking about reverse bias. We are going to study the reverse bias characteristics of a given photodiode. Now this is the variable supply. As I told you, 0 to 12 volt. This is the arrow denotes that it can be varied. So we are using a potentiometer to vary the supply, and the output from this supply is given as input to this circuit. We have a photodiode. So this is a photodiode. The symbol of the photodiode is like this. So you take, so light comes and falls onto the photodiode, then you have the current. So as more and more light falls on it, you will have the current increasing. So that is what we are going to study. So this is the symbol of the photodiode, where this is the positive and this is the negative. So how are we connecting this diode, this photodiode in the circuit? If you are talking about this is positive, so this is positive and this is negative. And the positive of the power supply is connected to the negative of the photodiode. So we are connecting the positive to the negative of the photodiode. This is what we call as reverse bias, and the negative is going to the positive. Now here we have an ammeter which is used to measure the current 0 to 200 microampere, and a fixed resistance of 1 kilo ohm. And across the photodiode, we connect a voltmeter that is in parallel to the diode to measure the voltage. So these are the connections in the circuit diagram. Now what is the theory behind it? A photodiode is a 2-terminal PN junction device. Photodiode is nothing but a PN junction device which operates in the reverse mode. It will have a small transfer which falls on the diode near the junction, and this is the symbol as we have discussed. So light falling onto the junction of the diode. This is the positive, this is the negative. So at the junction the light falls, and the reverse bias current is produced by the thermally generated electron hole pairs. So because of the light that is falling on it, there are whole electron pairs that are generated. They are generated thermally because of the heat. We say thermal means always related to heat in the depletion layer. And these charges are swept across the junction by the electric field created by the reverse voltage. We are applying a reverse voltage to this PN junction diode or the photodiode, and because of the reverse voltage, what happens? These electron hole pairs can be swept across the junction, which gives rise to current. Now, in a photodiode, the reverse current, the current that is produced due to the reverse bias, we are calling it as a reverse current. It increases with the light intensity. As the amount of light that falls on the photodiode increases, the reverse current also increases. And when there is no light that is incident, the reverse current is negligible. We call it as dark current. So, no light incident on the photodiode, so there is no current, so we call it as dark current. And an increase in the amount of light produces an increase in the reverse current. As you keep on varying the amount of light, the amount of current also increases. The reverse current also increases.
Let us now see the demo of how to study the voltage versus current characteristics of a given photodiode. The aim of the experiment is to study the VI characteristics of a photodiode with different intensities of light. The apparatus required is a photodiode, an external source, here we use a lamp, then a photodiode characteristics kit, which consists of a power supply, a variable power supply 0 to 12 volt, and then an inbuilt voltmeter, ammeter, and a fixed resistance of 1.5 kilo ohm. And also we have a provision to connect the photodiode in the circuit. Let us see the circuit diagram and connect it. We have a variable power supply 0 to 12 volt connected to the diode, photodiode, in reverse bias. Now we have 1 kilo ohm resistance here and a voltmeter to calculate the voltage across the photodiode. Now let us start doing the connections. From the power supply, connect it to the negative of the photodiode because we are doing it in reverse bias. Let me tell you about the photodiode. A photodiode is a two-terminal PN junction device which operates in the reverse mode. When light from the external source falls onto the photodiode, the thermally generated electron hole pairs will be swept across the junction because of the reverse voltage we are applying. So we always connect or use it in the reverse bias mode. In reverse bias, we connect the positive of the power supply to the negative of the photodiode. Now we have already connected positive to negative, and from the negative we will connect to the positive. So now this photodiode we have connected in the reverse bias. Now let us connect the ammeter. Ammeter is used to measure the current in the circuit. Here, as I told you, the ammeter is inbuilt and we have a provision to measure the current in milliampere or microampere in the range of 200. Because we are using it in the reverse mode, the current is always due to the minority carriers. Therefore, it is very small. We measure the current in microampere. So, let us put it in the microampere mode and connect the ammeter. We will connect the ammeter from these two terminals. The output from here is given as input to the circuit. So we have connected the ammeter. There is a resistance of 1.5K and the photodiode is connected here. Now we need to connect the voltmeter. One thing you need to understand here is an ammeter is always connected in series in a circuit and meter is always connected in parallel. So we connect it positive to positive and from the negative to the negative. So the circuit connections. So the circuit connections are done. Now to start with, we will see that this potentiometer which is used to vary the voltage is in minimum position and also the light intensity is minimum. Let us switch on the supply. Now we will adjust the distance between the photodiode and the power. The source fixed and the intensity of light can be used or varied using the lamp control. So for a fixed intensity of light, now what we are going to do is we are going to vary the voltage and note down the current. So using the potentiometer, we can vary the voltage. So let us note down the reading. The initial reading 0.01 voltage, we have a current of 3.3 microampere. As I told you, it is in micro. Now let us vary the voltage in steps. Let us put minus 0.5. We see it as minus because we are doing it in the reverse bias. So in the reverse bias, we read the voltage as negative and also the current negative. So for a voltage of 0.5, you have a current of 3.7. So let us now increase in incremental steps of 0.5. So let the voltage now be 1. So the current is 4.2. 1.5, 4.6, 2, it is 5. Now let us increase it in steps of 1 volt, for 3, 5.9, for 4, it is 6.6, for 5, is 7.4, for 3, for 7, 9.1, 8, it is 9.8, then 9, 10.7, 10, 11.5, 11, 12.3, and 12, 13.4. So we are going to vary the voltage from 0 to 14. Note down the voltage versus current, as down the voltage as well as current. Now let us do the same set of readings for a different intensity. We can use the lamp control to increase the intensity of light. Switch it off, switch off the kit, keep the potentiometer in the minimum position and vary the intensity of light by switching on the quit. So you can see the intensity of light increasing. Now we will again note down the values of voltage versus current using the potentiometer. We can vary the voltage using this potentiometer initially in steps of 0.5 and then in steps of 1 volt. So let us now compare the readings with the previous values. So at 0.5 we have 8.4. At 1 it is 8.9. 1.5 9.3. At 2 volts it is 9.7. So if you compare with the previous intensity, always the current is more. So in case of a photodiode, as the intensity of light increases, the photocurrent also increases. We can do it for a different set of readings by using the distance method. One method we have seen is to vary the lamp control, and the second one by varying the distance between the source and the photodiode. Also the intensity of light varies, because as the distance increases, the intensity of light that falls on the photodiode decreases. So you can take one more set of readings by varying the distance between the two. As you bring it near to the source, the amount of light that falls on the photodiode increases, so the intensity increases. And if you note down the values, so for the same voltage, the current will be even higher. Say for 0.5 volt, now the current is around 36. See, because the distance is very less, means the intensity is high. So for a voltage of 0.5, we are getting around 35. Now again vary the voltage in steps of 0.5 and note down the current. So note down the readings from 0 to 12 volts and note down the readings. After noting down the readings, we need to plot the graph for voltage versus current. Because we are using reverse voltage, we get reverse current. So the graph will be in the third quadrant, minus x versus minus y. As the values of voltage increases, the current increases and gradually it becomes constant. So this is for a first intensity we have seen. So after increasing the intensity, the second intensity and also the third intensity. So what we are studying here is the VI characteristics for different intensity of light, and what we conclude here is as the voltage increases, the current increases, and with the intensity of light, the photocurrent increases. Yes, let us see what we have seen. We have switched on the trainer kit. We have set the potentiometer in the minimum position first, and we have connected the DC source which is inbuilt, and we have switched on the bulb. Means when the bulb is on, the light will come and fall onto the photodiode. We have connected the microammeter and the voltmeter, and now we are adjusting the voltage in incremental steps, and we are measuring the voltage and the corresponding current. From the 2 meters we have on the kit, we are measuring the voltage as well as the current, and now we are going to draw a graph for VR versus IR. VR stands for the reverse voltage and IR stands for the reverse current. And we are going to repeat the steps, all these steps for different intensities of light. We are going to vary the light. There are two ways in which you can vary the intensity of light. One is on the kit, you have a lamp control where you can increase the intensity of light so that the amount of light falling on the photodiode increases. Or the other way is to decrease the distance between the source, the lamp and the photodiode. As the distance decreases, because it is inversely proportional to the square of the distance, the intensity of light increases.
So either way you can do. Either you can use the lamp adjustment or the lamp control, or you by varying the distance between the source and the photodiode. Now let us see the readings. We are going to tabulate for different values. So let us first concentrate on these two columns. For a given voltage, so we have kept the intensity of light constant. So this is for a particular intensity, I naught. I naught is the intensity of light. We are going to measure the currents here. Okay. Now for -1, why we are writing -1? As I told you, we are talking about the reverse voltage as well as the reverse current. So we will be seeing the display as negative. So for -1, -2, we are going to increase the voltage in steps of 1 volt and note down the corresponding current readings. Now you vary the intensity, vary the distance or the lamp control and repeat all the steps. Means you will keep on varying the voltage again in steps of 1 and then you will note down the readings. For another intensity also you will keep on noting. So assuming that the intensity of light increases. So what you are observing here, you see. So for the same voltage, as the intensity increases, the amount of current is going on increasing. Here it is 49.9, 53.3 and 55.6. This is a point to be noted. So what we are observing here is as the intensity increases, and for a given voltage, the current increases. And as you keep on varying the voltage, the current also increases. As you vary the voltage and as you vary the intensity. This is what we are going to study now with the help of a graph. Now, how is the model graph? We are only talking about the reverse characteristics. This is the forward characteristics. These are the reverse characteristics. We call them as reverse characteristics. So first, for a particular intensity of light, we keep on plotting the graph for voltage along the minus x-axis and current along the. So this is the third quadrant we are seeing here, where you will be having all minus values. Both the values of x and y are negative. So because we are talking about the reverse bias. So this is minus x, if this is plus x, y and minus y. So all these values correspond to the first intensity. You will join all of them so you get a line like this. This is for the first intensity, intensity 1. Now again for the second set of readings, for different voltages we have different currents. Again you join these, you get a line like this. So for the third intensity you will be plotting the points and the curve is like this. So you can compare now, as the intensity of light increases, the current also increases. So of course this is in microampere. So the current is in microampere and the voltage is in volt. Now what we are observing as a result, the VI characteristics are studied for different light intensities, and what we are observing here is as the intensity of light increases, the reverse current also increases due to the reverse voltage that is applied. Thank you.
Like, share and subscribe. Hit the bell icon for more.
Back to the class. Watch the video, Amma.
Yes, sir.
Is there any voice issue or anything else? Voice issue ఏమైనా ఉందా?
కొంచెం లాగ్ ఉండే సార్ అంతే.
Okay. So one of the simplest experiment only. Sorry. Coming to the experiment in reverse bias. Reverse bias, when the PN junction or LED is connected in the reverse bias, so it acted as a photodiode. So reverse current, due to reverse current, so photodiode observes some light energy and converting to the electrical energy. So here how it is converting for different intensities we are going to observe in this experiment. Photodiode, how it will be behaves by applying different intensities, by giving different intensities. I think all of you know about the function of photodiode. What is the function of photodiode? It observes light energy and converting it to the electrical energy. So sorry. Yeah, only draw the reverse characteristics, no need to draw the forward characteristics. Already we calculated the forward characteristics in the LED experiment, right? So no need to draw the reverse characteristics in your graph also, only take the reverse characteristics. Voltage we are taken on the negative x-axis and current we are taken on the negative y-axis. And for different first intensity, when you draw the graph, you are getting like this. So for the different, when the intensity increases, so light energy falling on the photodiode increases and converting energy also, light energy converting into the electrical energy also increases. So take any three different intensities from the experiment and note down the voltage and current values for the different intensities. So voltage will be the same. So from we are varying from 0 to 12 here. So up to 2 volts increase 0.5 voltage, 0.5, 1 volt and 1.5, 2. After the 2, by increment of 1 volt, note on the current values. So 5, 6, 7, 8 up to take the 12 volts. So for a particular intensity, you note on the current values. After that, increase the intensity. How we are going to increase the intensity? Already madam clearly explained. There is two ways to increase the intensity. One is by increasing the light intensity, or else the decrease the distance between the light source to the LED. Okay, so we have two ways to increase the intensity of light. Intensity falls on the LED photodiode. One is, so we have a knob to increase the light intensity. Use that method, or else decrease the distance between the photodiode to the light source. Then also we are increasing the intensity, means light intensity falls on the falls on the photodiode will increases by decreasing the distance between the two. So for the particular intensity, there is no particular rule to kept that intensity. So take one intensity and note down the current values for this voltage. So after that, for the same potential, by taking the same potential, observe the current values for the another intensity. So repeat the experiment for the 3 intensities at least. That is I0 first intensity, I1 is the second intensity, and I2 is the third intensity. So for the same potential, using the potentiometer, observe the current values for the 3 different intensities and note down in the tabular form. After that, plot the graph by taking voltage on the negative x-axis and current on the negative y-axis. So draw the graph. You are getting graph like this. This is what we are going to observe in this experiment. VI characteristics of photodiode means by given different intensities, how much the current is, how much the light energy converting into the electrical energy, we are going to observe in the photodiode experiment. Clear that? It is very clear. For different intensities, we are going to observe VI characteristics of photodiode. Before that, you have to know what is the function of photodiode. What is the function of photodiode? It converts light energy into the electrical energy. If your light falls on the photodiode increases, so converting into the electrical energy also increases. That is the theory. That theory are we are going to observe in the experiment. Okay. I'm going to share that PDF of photodiode. Please hold on, all of you. ఏం చేస్తాం అన్నా? So I'm sharing the PDF of that photo diagram. See, is the screen is visible? Screen is sharing, amma. Share out the screen.
Yes, sir.
Yes, sir.
Yeah. See, wait. Energy of semiconductor. Photo. This is the photodiode experiment. So you have to write that introduction about the photodiode in your worksheet. So after that, object to nothing but this experimental aim of this experiment is this one, to draw the VI characteristics of photodiode for different light intensities. After that, so background also no need, applications not now, not required. So draw the circuit diagram. This circuit diagram is compulsory. Experimental procedure, only reverse characteristics we are going to analysis. That's why experimental procedure you have to write in your worksheet. So after that, observation table. So model graph and result. These things you have to write in your worksheet. So again, I am repeating. Introduction compulsory, amma. So after that, aim of that experiment to draw the VI characteristics of photodiode for different light intensities. So this reading pre-lab not required, amma. Background also not required. Applications also not required. So circuit, keep the heading circuit diagram and draw the circuit diagram. And experimental procedure you have to write, amma. Experimental procedure, reverse characteristics. Only 6 points are there. So after that, draw the observation table. Take 3 different intensities and note down that observations. Okay, I'm going to share after this class. I'm going to share that observations like the previous experiment in your WhatsApp group. So after the observation table, draw these 2 diagrams, representation of photodiode, symbolic representation of photodiode. Draw the model graph. Keep the heading here, model graph. So after that, write down the result. VI characteristics of not pin and avalanche photodiode. Okay. Photodiodes are studied. So answer for the YOY's questions. Okay, ma. These things you have to write in your worksheet. Is it clear, amma?
Yes, sir.
Give me doubts on VI characteristics. And about your worksheet. So introduction and aim of that experiment. So after that, circuit diagram. This is a circuit diagram. Experimental procedure. Observation table. Symbolic representation of 2 diagram, and symbolic representation of photodiode, and model graph. After that, result and answer for the YOY's questions. These are enough to write the worksheet. Operators leave, sir. So see the right operators are see the diagram and write on the operators, amma. What are the operators we are going to use here? Power source and resistor, photodiode, ammeter, voltmeter, and connecting wires. Okay, variable power source, ammeter, voltmeter, photodiode, resistor, and connecting wires. And bulb, electrical bulb also, to increase the intensity or to vary the intensity, electrical bulb we are going to use. Okay, that are the operators. You try to note down. What are the operators? Variable power source, that is 0 to 12 volts. Ammeter is varying from 0 to 200 microamps or 0 to 20 milliamps. So when we are connected in a forward bias, we are using the milliamps. but here reverse characteristics now we are using 0 to 200 microamps. After that, resistor, photodiode, electrical bulb, connecting wires. These are the operators. Ammeter, voltmeter also, sorry. Voltmeter, ammeter, resistor, photodiode, electrical bulb, and connecting wires. These are the operators. దీనిలో కూడా బ్యాక్గ్రౌండ్ రిటర్న్ పార్ట్ రీడింగ్ పార్ట్ ఇవన్నీ అవసరం లేదమ్మా. ఓన్లీ కీప్ ద aim of your experiment to study the VI characteristics of photodiode for different intensities. After that, write down the introduction తర్వాతనే ఏం రాయండి, ఏం రాసిన తర్వాత circuit diagram. Before that, write down the operators. After that, circuit diagram, experimental procedure, observation table, and these two diagrams. So after that, model graph, result, and viva-wise questions. These are enough. Sir, model graph is enough, or we should take the graph and draw? So when you have model graph, the drawing graph is compulsory amma. Model graph undante graph draw cheyalsinde. Sir, what about plotting of points on original graph? So what you observe, I'm going to give that observation amma. After this class, I'm going to share that observation. Using that observations, all of you try to draw the graph by taking voltage on the negative x-axis and current on the negative y-axis. I'm going to share that observations. You have to enter that observations in the observation table. Voltage we are varying from 0 to 12 now. We are taken initially up to 2 by incremental of 0.5 volts. We are going to observe the current values. After the 2 volts, by increasing in 1 volt. Increment of 1 volt, we are going to observe the current values, because of we are getting more number of observations. Still, if you are having any doubts,